Now let us see how we can work with servo motor and Raspberry Pi. For this we require a servo motor, jumper cables and a Raspberry Pi. In servo motor there are three wires in which the brown wire indicates the ground, the red wire indicates the power connection and the orange wire indicates the GPIO connection. So now let us make the connections. Now let us give the power connection, that is our red wire, to pin number 2, the ground wire to pin number 6 and the GPIO pin 11 of Raspberry Pi. So our connections are done. Now let us run the code.
Now let us see the code for working with the servo motor. First, we have imported the Python library rpl.gpio for working with Raspberry Pi and another library to provide the functionalities for working with time. We start by providing GPIO pin 17 as the output pin to the Raspberry Pi using the variable servo pin. Another object P is used to provide a 50 Hz frequency conversion of digital signals provided by Raspberry Pi into analog signals. We start the execution by initializing the object P. With this initialization of 2.5, the servo motor starts the rotation of its shaft. Later, with a change in the value of this position, which was earlier 2.5, the duty cycle of the servo motor changes. When the duty cycle changes by a large amount, the servo motor rotates with a higher speed. As this value goes down, the servo motor slows down. In between, we have provided a delay of 0.5 seconds. Finally, when there is any keyboard interrupt like pressing Ctrl and C, the servo motor shaft stops rotating. Now, let us see the output when this code is executed.
After running the code, we can see that a servo motor is rotating in clockwise direction for 180 degree and anti-clockwise direction of 180 degree.